Good day, word workers! It is I, your chief word worker, Miss Tan, and today let us talk about sampling in the context of quantitative research. Note that these information are directly lifted from Kumar and Johnson and Christensen. Let's keep going! So here are our targets. First, discuss the principles of sampling. Second, discuss the different quantitative sampling methods. The selection of a sample in quantitative and qualitative research is guided by two opposing philosophies. Here are the general characteristics and purpose of sampling in quantitative research. First, sampling in quantitative research must be unbiased and must represent the population from where it is selected. Second, the purpose of quantitative sampling is to draw inferences about the group from which you have selected the sample, meaning the sample must be the representative group of the population so that your findings may be generalizable. Regarding the sample size, quantitative researchers are guided by a predetermined sample size that is based upon a number of other considerations in addition to the resources available. What is sampling? According to Kumar, sampling is the process of selecting a few from a bigger group to become the basis for estimating or predicting the prevalence of an unknown piece of information, situation, or outcome regarding the bigger group. Similarly, Johnson and Christensen defined it as the process of drawing a sample from a population. Sampling means studying the characteristics of a subset that is called the sample selected from a larger group to understand the characteristic of the larger group. This time, let's talk about the principles of sampling. First, in a majority of cases of sampling, there will be a difference between the sample statistics and the true population mean, which is attributable to the selection of the units in the sample. Again, this boils down to the sampling technique or method that the researchers shall use. They must ensure that the sample is a representative group of the whole population. Principle 2, the greater the sample size, the more accurate the estimate of the true population mean. So remember, in quantitative research, we are always after generalizability. And the third principle is, the greater the difference in the variable under study in a population for a given sample size, the greater the difference between the sample statistics and the true population mean. As you would notice, these principles are all connected to the method of selection of the sample size. The smaller or bigger the difference is between the sample size and the population, the more or less accuracy and generalizability the results reflect. Of course, our main goal is for the difference or error to be smaller. So here comes the sampling methods. Let us talk about the different sampling methods and designs under quantitative research. Take note, there are two major designs. They are probability or random sampling and non-probability or non-random sampling. Let us dive more deeply. The first one is random or probability sampling, where each element in the population has an equal and independent chance of selection in the sample. So here are the three popular methods for random sampling. First one is the fishbowl draw, second is computer program, or the third is table of randomly generated numbers. So these are some techniques. So in the fishbowl draw, if your population is small, there is an easy procedure, and that is to number each element using separate slips of paper for each element, and then put all the slips into a box and then pick them out one by one without looking until the number of slips selected equals the sample size you decided upon. This method is used in some lotteries. So it's like a fishbowl or lottery method. The second one is the computer program. So there are a number of programs that can help you to select a random sample. For me, I do use the Wheel of Names online. And then the third one is a table of randomly generated numbers. So most books on research methodology and statistics include a table of randomly generated numbers in their appendices. You can select your sample using these tables actually. So here are the specific designs under probability sampling. First one is the simple random sampling, where each element in the population is given an equal and independent chance of selection. So the most commonly used method of selecting a probability sample. So in line with the definition of randomization, whereby each element in the population is given an equal and independent chance of selection, a simple random sample is selected. So the second is stratified random sampling. The research attempts to stratify the population in such a way that the population within a stratum is homogeneous with respect to the characteristics on the basis of which it is being stratified. So as discussed, the accuracy of your estimate largely depends on the extent of variability or heterogeneity of the study population with respect to the characteristics that have a strong correlation with what you are trying to ascertain. It follows, therefore, that if the heterogeneity in the population can be reduced by some means for a given sample size, you can achieve greater accuracy in your estimate. Stratified random sampling is based upon this logic. Now, stratified random sampling has two types, the proportionate and disproportionate stratified sampling. So with proportionate stratified sampling, the number of elements from each stratum is in relation to its proportion in the total population is selected, whereas in disproportionate stratified sampling, consideration is not given to the size of the stratum. So for example, when you say proportionate stratified sampling is strata number 1 is greater than strata number 2, then you get more samples from strata number 1 than strata number 2. But for disproportionate stratified sampling, you do not consider the number of participants in each of the strata. So for example, your target is to just get 5 participants or samples from each strata, then so be it. So you do not consider the number of members or participants in each of the strata. So I hope that is clear. Another example or another design under random sampling is the cluster sampling. So it's a form of sampling in which clusters or a collective type of unit that includes multiple elements such as schools, churches, classrooms, universities, households, and city blocks rather than the single unit elements. They are randomly selected. So simple random and stratified sampling techniques are based on a researcher's ability to identify each element in a population. It is easy to do this if the total sampling population is small. But if the population is large, let's say as in the case of a city, state, or country, it becomes difficult and expensive to identify each sampling unit. In such cases, the use of cluster sampling is more appropriate. So those are the common designs for probability sampling. Let us now discuss non-probability sampling. So when we say non-probability sampling design, they are used when the number of elements in a population is either unknown or cannot be identified individually. Here are the specific designs under non-probability sampling. First one, accidental. Second, snowball. Third, quota. Fourth, expert. And fifth, judgmental or purposive. For the quota sampling, the main consideration directing quota sampling is the researcher's ease of access to the sample population. So the sample is selected from a location convenient to you as a researcher, and whenever a person with this visible relevant characteristic is seen, that person is asked to participate in the study. The process continues until you have been able to contact the required number of respondents, or what we call the quota. So accidental sampling is also based upon convenience in accessing the sample population. So this method of sampling is common among market research and newspaper reporters. It has more or less the same advantages and disadvantages as quota sampling, but in addition, as you are not guided by any obvious characteristics, some people contacted may not have the required information. So be careful in using accidental sampling. Judgemental or purposive sampling. This is also very popular, where the researcher specifies the characteristics of the population of interest and locates individuals with those characteristics. So, the primary consideration in purposive sampling is your judgment as to who can provide the best information to achieve the objectives of your study. You, as a researcher, only go to those people who, in your opinion, are likely to have the required information and be willing to share it with you. And then we have the expert sampling. So in the case of expert sampling, your respondents must be known experts in the field of interest to you. So the only difference between judgmental sampling or purposive sampling and expert sampling is that in the case of the former, okay, the case of purposive is that it is entirely your judgment as to the ability of the respondents to contribute to the study. But in the case of expert sampling, your respondents must be known experts in the field of interest to you. And last but not the least, we have snowball sampling, where each research participant is asked to identify other potential research participants. So it is the process of selecting a sample using networks. So to start with, a few individuals in a group or organization are selected and the required information is collected from them. They are then asked to identify other people in the group or organization, and the people selected by them become a part of the sample. So information is collected from them, and then these people are asked to identify other members of the organization, and in turn, those identified become the basis of further data collection. This process is continued until the required number or a saturation point has been reached in terms of the information being sought. I hope you're able to shop for your sampling design in your own quantitative research. Those are the essential information that you need to know about research sampling. All the best, young researchers. Give it your all and stay in school. Bye, everyone.